Hi, and welcome to today's math lesson with Mr. Douglas. It's time to reflect on things. Reflections, more specifically. Yes, we're going to learn how to make things look like the same thing across different planes. Here we go. So before we start talking about reflections, which is going to be the second part of looking at different kind of transformations, did everybody notice in the intro part the reflections in the eyes of the different Star Wars characters? And if you did, what character is being reflected in each one's eyes? They're all from the original episodes, 4, 5, and 6. It is, pretty neat. So you might want to just pause this, go on back, and check that out. So for today, now that we're looking at another one of the transformations, we've already done translations. You can go back and check out that video if you need to. But today we are looking at reflections. And if you're like me, my first probably experience of reflections was in a grade one kind of maybe art class. And what they had you do was you had a kind of like a mirror. You were given a mirror and you had like a piece of paper, and then you had to go and draw yourself, the half of your face or something like that, and then you had to go draw the other half of your face, and you had to make it all kind of look the same, and you had like half a smile here. This is a horrible drawing, by the way. And you had another half smile, another eyeball, and that kind of stuff. And then you basically had to notice that when you have a mirror, you're getting a reflection of equal kind of proportionality, and you kind of looked at it that way. So that's kind of the idea. We're going to be looking at reflecting, and for us though, we're looking at, if I take an image, let's just say I had a trapezoid, since we kind of are working about like trapezoids a little bit. If I had this trapezoid, and remember the trapezoid has 4 kind of vertices there, and if I reflected it across a line, and it's important to know what line it is. I'm going to say across the y-axis here. If I reflected it across here, what would it look like over here? So imagine you're literally flipping it across. And if you did that, basically, you'd get something that would be like this. Now, it looks like it got enlarged. Imagine it's not enlarged. It's the same size, same shape, but it's basically having the same distance between the points. So the distance here is equal to the distance there, and so on and so forth. So these are all going to be kind of equal. And it gets reflected across. Okay. So the big thing is, for when we're reflecting, you get the same size and shape. Therefore, the images are congruent. And the other thing is, the line of reflection is really important. The line of reflection. And you're going to be asked to reflect things across different types of lines. So you need to make sure you know which one it is. Now, some students will just go and literally just count. If it's across the y-axis or the x-axis, it's not too bad. If it's set up like this, it's not too bad. Like, you could just count, like, it is 3 spots, let's say, away from the y-axis. So that means over here it has to be 3 spots. You could just count that and just like draw the other dot. That's absolutely fine. It gets a little bit more complicated. Imagine if your trapezoid was like this though, and I asked you to reflect this across the y-axis. That can be a little bit more tricky as you look at it, because you would end up getting kind of like an image that would probably be a little bit like this. So it gets a little bit more tricky as you kind of look at it that way. But there are some rules. There are rules, of course, to make your life a little bit easier. So there is a magical box of rules. I know you're very excited. First off, let's talk about the different types of lines there are. So just a quick little reminder about what different lines look like. So this is your y-axis, and this is your x-axis. So if you had something that said reflect across the y-axis, you're reflecting across this line right here. And then you have the x-axis. Okay, so maybe I'll use different colors too. Let's say this is the x-axis. So we have that. So we have green for the x-axis and we have red for the y-axis. So those are two lines that are commonly used. We also can maybe use some yellow. We also have lines that are y equals x. And y equals x goes through the origin and has a slope of 1. So it rises and runs 1. It's very nice and easy that way. And there's also y equals negative x, which is a downward slope. And it goes through the origin. And again, the slope goes down 1 and across 1. So those are the four main types. Sometimes you also have things where you have to reflect across a certain line. Like say, it'll say reflect across y equals -2. Across the line y equals -2. So this would be like y equals -2. And they want you to reflect across that line. Sometimes that will happen. But the box of rules, the box of rules, here's my box. You want to know this box? This is how I would go and do this. Sometimes I kind of struggled remembering what or like visually how to go and figure things out. So I liked having rules. So across the x-axis, what's the rule? So if you have a point xy, where does it end up if you have to reflect across the x-axis? That point will end up, little arrow, boom, at the same x coordinate, but the y will change. So I don't know if you can kind of visualize that. Let's just say you had this point, this random point. Say the point was right there, like this. So let's just say it was -5, 2, like that. And I have to reflect across the x-axis. So I'm reflecting across this one. So it's going to stay here, but it's going to be over here now. So it's still going to be at -5, right? The x stays the same. But now, instead of being at +2, it'll be at -2. So that's what I'm kind of meaning here. Now let's talk about if you had to reflect across the against the y-axis. So if you had to go across the y-axis, and I'll try and color coordinate all this for you guys. So again, what happens here? Now perhaps you can have a good guess of what would happen here. Across the y-axis, the x now will flip, kind of change, but the y would stay the same. And moving right along, let's say you had across the y equals x. So the classic line of y equals x. What will happen to our coordinates? Well, if you're going across y equals x, you're basically going to be switching your coordinates. So your x becomes your y and your y becomes your x. So if we're taking a look for the y equals x, we had to reflect that point again. Let's say we had to reflect that point -5, 2, and had to go across here. It would probably end up over here, and it would end up probably about there. And all you're doing is flipping this. So it's not -5, 2 anymore, it's 2, -5. So 2, -5. That's not too bad if you're reflecting across y equals x. And the final one that we have to look at, the purple one, is what happens if it reflects across y equals -x. So what would happen there? Now, if you can take a wild guess, what do you think happens for that one? Again, you're going to flip-flop, but you're going to be changing the sign. So it's going to be -y, -x, like that. So again, if we had, let's say we had this point, let's use that same point here, so that -5 and 2, I'm going to reflect across that purple line. So it's going to end up probably about here. So we're going to flip these and change the signs. So it's going to be at -2, so -2 and +5. So it'll be at -2 and +5. So the box is really important, and hopefully you guys can just kind of use that when you're going and solving all your problems. So let's see some examples. Let's say we had an example. Exampa gradius, that's what the EG stands for. Let's just say we had a point. So I'm going to say we had point A, and it was at 4, -7. And I'm going to say that it reflects across. So this is important, right? Where does it reflect? Across the x-axis. Where is it? So where does it end up? Where is it? Where does it end up? See if you can solve that one yourself. Let's see, so what is going to happen? Remember, you can always go back and just see, like, what are the rules? Okay, so x-axis, it looks like the x stays the same, so that x would stay the same, but I think the y is going to change. So that stays the same, so 4, and this -7 becomes +7, like that. What would that actually look like? So there we go. So we had 4, -7, so it's going to be somewhere around here, something like that. And it's reflecting across the x-axis, so it's reflecting across this one right there. So it's going to flip kind of up, if you had to look at it. So it'd be kind of there. It'd still be at 4, but now it would be at 4, 7, like that. So that's kind of what you're going to be asked to do, and going from there. Use the different rules, get to know them, and just practice. There you go. Thanks for doing the math with us and reflecting on everything, including reflections. Yes, reflecting on reflections. That's quite an interesting tongue twister. All right, until next time, have a great day.